Welcome back, Senior Devs. Sean Kanan here. In this lesson, we're going to talk about the importance of stability in your application. Mark Zuckerberg's famous quote, "Move fast and break things," is easily some of the most selfish and irresponsible advice I've ever heard in this industry. It's certainly an effective way to learn a new language or new technology. I do that all the time with new languages and frameworks. I'll intentionally veer from the happy path so I get comfortable with error states and failures, and then try to fix them from memory, reversing the steps I took to break them. The moment I'm using that technology on a project with people besides myself, I'm no longer in a position to learn through intentional failure because it puts the entire project at risk and causes frustration and confusion and wastes the time of colleagues and customers. Stability in your application equates to predictability in your application. Being able to predict how an app is supposed to work makes it easier to recognize when the application is not working as intended. If something in the application throws an error and other times works fine, it becomes a quirk in the system. People don't know how to reproduce it, so they can't fix it, and entire days are lost trying to recreate a scenario when someone experienced the bug. Stability comes from a variety of factors, including, but not limited to, unit test coverage, which we'll cover much deeper in its own module. Developer discipline, meaning using best practices and not cutting corners with hacks and patches. Thoughtful implementation, such as leveraging the strategy-based development versus condition-based development. Predictability in our projects allows us to refactor large portions of our code base because we should have unit test coverage to tell us if we broke something. It also makes it easier to A/B test features, which we'll also cover in a later module. Stability in our project can also be a little less literal and a little more meta, like our APIs, for example. Versioning and documenting our APIs allows us to create payload contracts, which in turn support integration testing efforts and cross-team collaboration. Anytime we break our APIs, we want it to be intended, documented, and ideally scheduled for a few versions after a deprecation notice has been added to the docs. The opposite of stability is volatility, which creates uncertainty. Nobody enjoys a volatile application, one that crashes all the time or throws errors occasionally during typical use. Nobody enjoys working with an API that changes its payload or response schemas on a whim. All of this causes disruptions, which causes frustration. Our objective as senior developers is to help alleviate frustration on our projects. We're supposed to be dependable and help deliver clean, consistent code so our clients or employers can spend more time focusing on their business growth and less time on their business maintenance. Keep this in mind when you are working with a legacy system. Clients and employers depend on a legacy system to run exactly as they are, and if you fix some bugs, you'll be a hero. But the moment you change or break one thing, it'll feel like everybody on the team will notice. If you are tasked with replacing a legacy system with a new one, I highly recommend that you prioritize stability over velocity. In my experience, most of the time these clients are in no huge rush to switch over to the new system. If the new system has any bugs or quirks that the old system doesn't have, you will feel immediate pushback on the new system. If you happen to break the old system while building the new one, even worse. Trust me, stability, stability, stability. Oftentimes, the product team overloads the dev team and insists that deadlines are met without tests and without QA. If you do have to cut corners to deliver something on time, make a technical debt ticket so you can refactor or add test coverage at the earliest opportunity. If you're on a team that never pulls tech debt tickets into the sprint and regularly forces devs to cut corners and deliver, I recommend looking in the mirror and asking yourself if this is the team you want to be on. Ask yourself, if you end up leading this engineering team, will you have any authority over the product team to handle technical debt or reduce sprint load to improve the engineering process? If the answers are no, then I'd recommend that you move to another project where the engineering team is more appreciated and respected. Depending on your project, you may be using third-party dependencies. Often on websites, 80 to 90% or more of the code that runs the application is third-party source code. Given this, even if we have 100% unit test coverage on our own code, if it ultimately only makes up 10% of the code being executed at runtime, then we need to do some serious due diligence when it comes to selecting and maintaining our dependencies. For starters, I almost always pick the LTS release of whatever library or framework I'm considering. For example, odd versions of Node.js are volatile and even versions are stable. So when I was running Node 10 in my app, not only did I wait for Node 12 to come out before I upgraded, but I went as far as to wait until Node released its deprecation notice of 10. So by then, Node 12 was like 12.15. Most of the time, the latest and greatest features in a dependency are nice to have and won't offer any real value to your application. This can easily be proven from that earlier module where I discussed trying to rebuild a simple app in multiple languages and frameworks. I'm fully confident that I could rebuild my current project in PHP 5 with patterns that I used 15 years ago. I find usually that the backend developers understand the risks better and are more in line with a slow and steady approach to development. In contrast, I find front-end devs tend to want to use the latest bells and whistles because they want to keep up with browser updates or mobile UI updates. This is an extremely risky mindset because not only are we essentially using our customers as guinea pigs to try out new libraries, but the view layer on most applications is often the most variable. While we're able to control the version and state of our backend layer, different users have different versions of browsers and operating systems installed, different screen sizes, different devices being used to view our application, and so on. When we roll out new code, we need to assess whether or not we need to support backwards compatibility. We need to have conversations with product teams before we start leveraging technology that will only be supported by a fragment of our user pool. Always remember that we don't have to make all these decisions. It's often best to present all the options, consult the pros and cons of each one, and let the key stakeholders on the projects make these decisions. Each team has its purpose, and engineering's goal should be to implement the product team's vision as accurately as possible, where the highest majority of work is on features, not bugs. That wraps up this module. Keep growing, and I'll see you in the next one.